Good day, everyone. Welcome back to another wonderful section of this tutorial class. Today, we are going to be looking at the topic motion under gravity. Motion under gravity and projectile motion. And the projectile motion. Remember the class we have done this topic, motion. Please ensure you look at these classes. They are very important and be very helpful to you. So I will refer you to them. Please ensure you watch these videos on motion. The ones you have done, equation of motion, and the geometric kinematics we did in the first class. So, but today we will look at another aspect of motion, which is a type of motion that's under gravity. Now, in this class, I'm going to be looking at two types of motion that can be influenced by. Now, what is the meaning of motion under gravity? Now, before I go to that place, you know you are not subscribed to this channel, please try and do so. When you subscribe, you will have the energy to do more video. And please, distance yourself from any distraction. Don't distract yourself by any means. And don't skip any part of this video. And please, turn on a notification bell. Just click on that notification bell so that anytime we release any video, you'll be the best person to see it. Then I will quickly just watch it and be blessed. So, let's look at this topic now. Motion under gravity. Now, what is a motion that is under gravity? Now, a motion under gravity is a type of motion that is influenced or are being affected by the acceleration due to gravity. Now, any motion of the body that is affected by acceleration due to gravity is what we call a motion under gravity. Now, we are going to be looking at two types of this motion, which is a motion that is thrown, okay, the motion of the body that is thrown vertically upward or projected vertically upward, and the motion of the body of an object that is projected at a particular angle. That is what we call the projectile motion. So, what are the equations we use in motion under gravity? Now, what I'm trying to say that is, let's say this is ground floor, and the body is projected vertically upward. Now, we're going to check the highest point the body can get to, we can call the maximum height of the body, the velocity at which the body will fall to the ground, the time taken to fall or the time taken to get to the maximum height. Now, this highest point this body can get to, if body is thrown vertically upward, is called the maximum height of the body. Now, the time taken to get to the maximum height and come back to the starting point is what we call the time of flight of this motion. Now, I will denote time to either get to maximum height or time to move from maximum height to the ground. Either the time to reach the maximum height or the time to move from maximum height to the ground. I will denote that time by small letter t. Now, if you look at this time is equal to the velocity of the body divided by acceleration due to gravity. That's what we're going to have at that time. Then, what about, I will denote the time of flight. That is the time to get to the maximum height and come back to the starting point again. The time to get to this maximum height and come back to the ground. I call that the time of flight. I will denote by calculator t. So the time of flight or the time to return back to Earth, if the body is projected vertically upward, is 2u over g. That is that time. It's 2u over g. Then, what about the maximum height this body can get to? The maximum height can be given as h is equal to u squared over 2g. H is equal to u squared over 2g. Now, let's assume, there's something we want to look at now. Let's assume a body is falling from a particular height, h. Let's assume we have a particular height, let's say on top of a tree. Let's say a body is falling from a tree or a body falling from a tower and so on, whose height is known, and we want to get the velocity at which that body will fall to the ground, or the time taken for that body to fall to the ground. How are we going to do it? Now, the time taken for a falling body to fall to the ground is given as T. Is given as T is equals to now the time taken for a body to fall. Let's say the time taken for if I leave a body in this place, my time taken for the body to fall from this place to the ground. If you know the height of this ball now, the time taken will be equal to the square root of 2 times the height divided by acceleration due to gravity. And the velocity of that falling body, is equal to the square root of 2g times h. Square root of 2g times h. That's not really the velocity of a falling body. The what velocity will fall to the ground. Now, I'm looking at some examples now. Now, take this question now. I just do introduction to projectile motion and motion under gravity. Now, let's look at this question. And please remember, acceleration due to gravity. Acceleration due to gravity is g. In this class, I will be assuming g as either 10 meters per second square, or I will take it as 9.81 meters per second square. These are the two values I may be using for g where necessary. So if you check all these equations here, all of them they are affected by g. So that's what we call them motion under gravity, motion that is affected by acceleration due to gravity. This g is what we call acceleration due to gravity. This g, you see it as this g, h is height, the height of the body. This is the velocity at which the body will fall, the time to fall to the ground. This one is trying to reach maximum height, time of flight, maximum height the body can get to is projected upward. Now, you take this question down. A stone is projected vertically upward. A stone is projected vertically upward. A stone is projected vertically upward with a velocity. A stone is projected vertically upward with a velocity of 50 meters per second. With a velocity of 50 meters per second, and attains its maximum height. Calculate the time taken to reach the maximum height. The time of flight of this body, or the time to get to the maximum height and come back to the ground. Time to reach the maximum height and come back to the ground, or the time of flight, the maximum height attained by this body. Take g as 10 meters per second square. Take g as 10 meters per second square. So let's look at this question now to see what we're going to have. Now, we said that a stone or a body was projected vertically upward with a stone, and this is the velocity of projection. They said, what is the time to reach the maximum height? And that time is u over what? Over g. So, what would be the time to get the maximum height now? With velocity 50. We said take g as what? 10. Divided by 10. You are going to have 5 seconds. 5 seconds. So this one we attain its maximum height in 5 seconds. In what? In 5 seconds. Then question 2. Follow me. Question 2. What is the time of flight of this body, or the time to get to the maximum height and come back to the ground again? That is what we call time of flight. The time to return back to Earth, or time to return back to the ground. Earth, so like the Earth I'm mentioning here denotes the floor or the ground. The time of flight will be 2u over g, that is 2 times 50 over 10. That is equal to 0 cancel 0 of 10 seconds, which is 2 times the time to reach the maximum height. The third one, what is the maximum height attained by this body? What is the maximum height attained by this body? Second line is what? U squared over what? Over 2g. U is what? 50 squared over what? Over 2 times 10. That will be equal to 50 times 50 over 2 times 10. 0 cancel 0. 50 times 5. What is that? 50 times 5. That's going to give us 50 times 5 will be equal to 250 over 2. 250 over 2. 2 here, we have 1. 2 into 5, we have 2, remember 1. Into 10, we have 5. So into 250, we are going to have 125 meters. This will be the maximum height attained by this body. So that's as simple as that. So if you know the right formula to use, you're already good to go. Now, let's look at this other question. Look at this other question. Question 2. Question 2. Take this question down. A stone and a feather. A stone and a feather. A stone and a feather were released from a height of 10 meters. A stone and a feather were released from a height of what? 10 meters. So, neglecting air resistance, comma, question A. Obtain the time taken for these two components, that is for the stone and the feather, to fall to the ground. What time will be spent, or what is the time taken for this stone, this feather, to fall to the ground, neglecting air resistance. Number 2, that is question B. Question B. Obtain the velocity at which both of them will fall to the ground. Obtain the velocity at which both of them will fall to the ground. What will the falling velocity? What will the falling velocity? That is the question. What will the falling velocity? Now, what you should know is that if you release a stone and a feather, we are looking at, you check the stone, the weight of the body. Remember the formula for, let's check for the first one. The formula for a body, the time of body to fall from the height is the square root of 2h over what? Over g. There is nothing there that talks about the mass of the body. So even though the mass of the stone is higher than the mass of the feather, which eventually give us an idea about the weight of this feather and the weight of the stone. Because the higher the mass, and as mentioned in gravity, the higher the weight will be. If the mass is very high and acceleration gravity is still high, the weight will be high as well, because weight is a component of both mass and acceleration due to gravity. You multiply it to have your weight. Then, look at this. In this equation, there is nothing like mass there. So the weight will not be present. So the weight or the mass of a stone and a feather will not choose the one to fall first to the floor. So, since we don't consider the forces acting or causing this motion in kinematics, both the stone and the feather will fall to the ground at the same time. Somebody don't hear that. I'm trying to tell you that all the stone, whether the stone is more heavier than the feather, there's no problem about that. Because how heavy they are is not inside the equation. So if you release the stone and the feather from that height, both of them will fall to the ground at the same time, neglecting air resistance. Neglecting air resistance. If there's nothing like air resistance, then you leave the stone and the feather, you fall together to the ground at the same time. So the technique for both of them to fall to the ground will be T is equals to the square root of 2 times h is 10 over 10. So you cancel 10. Our T will be the square root of what? 2. And what's the root of 2? Approximately is 1.41 seconds. 1.41 seconds or 1.4 seconds. Let us know it's 1.4 seconds. 1.4 seconds. Now, what velocity is for? So velocity is what? Velocity of a falling body is given as square root of 2 what? Gh. Square root of 2 gh. Think of that. Think of that. Then let's look at this to see. If you also check the velocity before, there is nothing like mass here. So both of them will fall using the same velocity. We will use the same velocity to fall to the ground, and we will get to the ground at the same time. So the velocity will still be equal to the square root of 2 times 10 times 10 again. We're going to have 10 times 10 to 100, then 100, 10 times 10, 100, times 2, everything will be 200. 200. And what will be the square root of 200? You do that from calculator, you have 14.14 meter per second. I'm going to fall to the ground in 1.4 seconds, and the velocity of actually will fall with 14.14 seconds. So let's look at projectile motion now. Projectile motion. Projectile motion. Now, this is a type of motion of a body. This is a type of motion of a body which describes a curved path or a parabolic path. Which describes a curved path or a parabolic path. Considering the diagram below, a body is projected at an angle theta to the horizontal. The body is projected at an angle theta to the horizontal with a velocity u meter per second. The velocity u meter per second. Obtain the time to reach the maximum height after projection. The time to reach the maximum height after projection. The range, the horizontal distance the body can go, or the range of the motion, the time of flight. Time of flight is well as the maximum range. Maximum range this body can go. Now look at it. Let's say this is our starting point. This is our starting point. We projected the body. Velocity of u meter per second. So if we project this body, it's going to move this way. Move this way. Fall back to the ground. Now the distance between this starting point and this end point is called the range of the motion. That is the horizontal distance, which denotes the range of the motion. It denotes the range of the motion. This is the x-axis. So from here to here, call it the range of the motion. Then the highest point of the curve, the distance between the highest point of the curve to this x-axis is called the maximum height the body can attain. Maximum height this body can attain. Then the angle of projection is with the x-axis, theta. So this call this our y-axis. This can be our y-axis here. This is our y-axis, our x-axis. So the time taken for the body to move from this place to this maximum height, the time taken at this point, call it the time taken very high, Now this one we call the time of flight. That is we're going to go from here to this, we call the time of flight. I think we're going to go from here to this, and maximum height, so the time to maximum height is denoted as u sine theta over g. U sine theta over g. What the time of flight, the time to return back to the ground is 2u sine theta over g. So that's the time taking going to return to the earth at the time of flight. Then the maximum height attained by this body, the maximum height attained by the body is given as u square sine square theta over 2g. U square sine square theta over 2g. While the range, the horizontal range of the motion, the horizontal distance of the motion is given as u square sine 2 theta over g. U square sine 2 theta over g. But the maximum range can be obtained to be u square over g. That is when theta is equal to 45 degrees. So somebody can ask you, for a projectile motion, what angle will give us our maximum horizontal distance? When the angle is 45 degrees, we are going to have maximum range. So if you project the body with velocity, let's say velocity of 10 meters per second, and you calculate from 0 degree to 90 degree, the one that will give you maximum range will be the one that will give you at theta is equal to 45 degrees. That's why you have the maximum range. You can try it. Try a question. Just take the question. Take theta as, let's say, take theta as value, let's say 0 degree, 10 degree, 20 degree, 40 degree, 30 degree, 45 degree. Then use a constant velocity. Ensure your velocity is constant for all. Check the one that will give you the highest range. The highest range will come when theta is 45 degrees. So take note of that. Take note of that, very, very important. So our G is still addition to gravity. U is the velocity of projection. Then you can know your sine is your trig function. Your trig function, you have your trigonometry. Then theta is the angle of progression, which is the result as you can see here. Let's look at this question. A body is projected. A body is projected at an angle of 30 degrees to the horizontal. A body is projected at an angle of 30 degrees to the horizontal with a velocity of 10 meters per second. With a velocity of 10 meters per second. Velocity of 10 meters per second. Obtain the time taken for this body to reach the maximum height. The time taken to reach the maximum height. The time of flight. The time of flight. The maximum height obtained on the highest point vertically this body can get to. The highest with the vertical distance body can get to, the maximum height attained, and the range, the horizontal range of the motion, and the horizontal range of the what? Of the motion. So let's look at this solution. Time taken to reach maximum height is what? U sine theta over what? Over g. That will be, say, okay, in this question, take G as 10 meters per second square. Take G as 10 meters per second square. We're going to have 10 sine, the angle is 30 over, we say take G as what? 10. So if this 10 cancel this 10, we're going to have sine 30, which is 0.5 seconds. So the time taken to reach the maximum height will be 0.5 seconds. That will be the time. 0.5 seconds. 0.5 seconds. Then, number 2. What about the time of flight of this body? That's taken to get the body and come back to the ground. That is 2u sine theta over g. That will be 2 times 10 times sine 30 over 10. So cancel this. We're going to have 2 times sine 30 is 0.5. And 2 times 0.5 is 1 second. So we're going to have 1.0 seconds. 1.0 seconds. That will be 1 second. 1 second. There's only 1.0 seconds. So you leave it as 1 second. So it's decimal. So I'm going to just put that one from decimal, which is still 1 second. Leave it as 1 second. Also put it as 1 second. Then I leave also leave it as 1 second. Yes. Alright. Then the maximum height attained by this body, u square sine square theta over 2g. It should be equal to 10 square sine square 30 over 2 times 10. So one of these 10 will cancel this 10. We're going to have 10 sine 30 everything squared over 2. 2 here 1, 2 here 5. So we're going to have 5 times, this is 1 over 2, which is half. I think this 1 over 2 is half. Square. That will give us 5 times 1 square is 1, then 1 over 4. 5 times 1 over 4. So the maximum height attained by this body will be 5 over 4. 5 over 4 meters. 5 over 4 meters. Or you can also convert that to decimal with your calculator. You can convert that to decimal with your calculator. Convert that to decimal with your calculator. Then you have a particular answer. Let's look at the range of the motion. The range of motion is u square sine 2 theta all over g. That will be 10 square sine 2 times 30 over 10. 10 will cancel 1 of this 10. We have 10 sine 2 times 30 is what? 60. That will be 10 times root 3 over 2. Sine 60 is root 3 over 2. 3 over 2. 2 here, 1, 2 here. Let's see, that will be 5. That will be 5, 2. That will be the horizontal range of the motion, 5 3 meters. You can also move this one to decimal to see what you are going to have. Alright, do that. This is the maximum height. The decimal will have 1.25 meters, maximum height attained. Then the horizontal range will be decimal should be 8.66 meters. That will be the answer for you. So look at this one more question. Look at this one more question. A golf ball. A golf ball is shot or projected at an angle of 30 degrees to the horizontal. At an angle of 30 degrees to the horizontal. Angle of 30 degrees to the horizontal. With a velocity of 44 meters per second. A velocity of 44 meters per second. How high does it rise? How high will it rise? If you project the golf ball at this angle to the horizontal, this velocity, how high will it get to? Or what is the height you get to? How high will it rise? How high will it rise is the maximum height it will get to. And the maximum height said is h is equals to u square sine square theta over 2g. So that will be 44 square sine square Sine squared 30 over what? Over 2 times. Now, in this question, take G as 9.81 meter per second square. Let's use that for this one. So, that will be 9.81. It will give us, solve this very well. We're going to do this 24 squared times sine 30, because you square everything, over 2 times 9.81. This is what we're going to do. If you solve that very well, you're going to have 24.7. Let's say 0.70 meters. Which are going to have as the maximum height. So please ensure study this topic very well. Solve further questions and be challenging in this topic. To do more videos, then follow us. Turn on our notification bell in case we are releasing more videos so that you'll be able to see it on time. See you guys in our next class. And if you have any question, you are free to watch this video over and over again in order to get everything. And if you watch this video over and over again and not to get the answer clearly, you are free to go to our comment section to drop the question there. So see you guys in our next class. God bless you. Thank you.